So welcome. I'm Sonia, and I'm the Associate Director for Dataverse Support and Data Curation with the Harvard Dataverse Repository and the Dataverse Project at Harvard University. And I will let Leonid introduce himself.
Hi, I'm Leonid Andreev. I'm a developer at the Dataverse Project, and I did a lot of work on this specific integration of Globus into Dataverse.
All righty. So let me just get this going. All right. So why are we talking about large data support? So there's been an increased demand for this larger data support. As you know, over the past 20 years, data has just been getting larger and larger and larger and more compute intensive. So we've been getting requests for large data support over the past maybe 10 years, I would say. And we were able to finally put together services and infrastructure for their support in the past few months. And there's also been an increased interest in computing on the data collections and being able to have more interoperability with the data. So for Harvard Dataverse Repository and requests that have come into our system for using large data support, we've had over 120 that we've tracked over the past 5 years. And we only looked at 5 years, so there's likely more of those requests sitting in our support queue. We get them from hospitals, Harvard and non-Harvard research groups, US government departments that typically have a lot of data. You can think about, for example, census data. And we're talking about projects that are anywhere from 1 terabyte to 650 terabytes of storage. So people are requiring or asking for different levels of access to data for a large number of files. Even if the files are not terabytes in sizes, they may have thousands and thousands and thousands of files that they need to share for access. There are inquiries about collections that will grow every year. So we have inquiries coming in about projects that will be versioned on a schedule yearly, every 5 years, however it is that there's always demand for growth. And of course, there's restricted content that still falls under large data support. Again, large data is about, we're talking about size and number of files, but you're still dealing with sometimes content that needs to be restricted under and managed access employed. And the retention period. We get a lot of questions about, well, how long can you hold this, right? Indefinite retention periods. For the Harvard Dataverse Repository, we don't get rid of data. So we do have indefinite retention of data. Our policy does not require that we remove or deaccession real data. We only remove content when it's legally requested or we find some issue about, the data that needs to be removed. And of course, people need budget-friendly options. It becomes really expensive to share large data if you do not have options that are sustainable for both the institute that's providing the service and the researcher, project group, organization that's trying to share the data for long term. So we can look at some of the models for infrastructure support of large data. And what I want you to see is that we have some immediate access options in terms of NESI disk, and then look at the price model that comes with these options. For immediate access, we're looking at NESI disk, some intersection with AWS, Google Workspace, Microsoft, Amazon Glacier, but the price increases for these immediate access options. For rarely accessed data, you also have some intersection of options here. And as you can see with the NESI tape, it's not very expensive for large amounts of data, and then small amounts of data, you have some other options that you can utilize. But these are all the options that we looked for in creating a service that we can provide through our repository. So here are the infrastructures that we looked into: the Amazon Web Services, right? Massachusetts Green High Performance Computing Center. We have the Northeast Storage Exchange and New England Research Cloud. So we looked at all of these options in terms of what we could integrate with and provide access through via our Globus integration. So what does this large data support infrastructure look like if we just take a look at the details? For AWS, right, we're talking about flexible storage, dynamic file access, Nessie disk, large data storage, immediate access, Nessie tape, intermediate access. But what you have to also look at is the flexibility of each of these infrastructures, right? And what the expectations are for file packaging when you have to use these services, okay? So if you look at, for example, Nessie disk and Nessie tape, we're talking about file size limitations and file size limitations, right? 2 terabyte maximum, 100 megabytes maximum. File count limitations exist for all of these. So when we developed our support, part of that includes a nice little table that allows you to see how you need to package the data to use any of the infrastructures that you are requesting when you fill out our request form for this support. Okay, so those all detailed in our large services website, large data support website, and I've included some of those screenshots in today's webinar so that we can discuss them a little more in depth. And you can go ahead and continue putting your questions in Q&A. I'll look at them as soon as we finish with the slides. All right, so what do we have now in Harvard Dataverse Large Data Upload and Access, right? So we had a project with Harvard University called the Harvard Data Commons Project that seeks to integrate and expand on all of the ways that data and infrastructure are supported across Harvard. So what we have now is, upload through Dataverse. You can upload a certain amount of content. In the Harvard Dataverse Repository, the default file size is 2.5 gigabytes per file. We are going to establish some limits on how many files you can put into any data set, because when you get over, say about 500 to 1,000 files, then the system doesn't react well to having to paginate through 1,000 files. And it also doesn't work well when a user comes in and they need to download over 1,000 files. And we have a few examples of these already in the repository, and we can definitely see how it does not work for the researcher. Even if they deposit that content through an API, when you have 60,000 files in a data set that's not using a large storage infrastructure, it becomes a real problem for the reuse of the data. We allow direct upload download through to S3 right now. So if you make a request to support a larger collection, we take into account your institutional affiliation. We take into account the discipline you're in, and then we decide whether we allow you to upload larger per file larger files, but you still have to stick to the 1 terabyte total storage limit for non-Harvard affiliates and 2.5 terabyte storage limit for Harvard affiliates. So there's still those considerations on limitations. Now we have this Globus transfer to file and tape, really. S3 is not yet enabled for use, but Leonid can talk more about that. Right now, we're doing most of our Globus infrastructure support or integration support with Nessie disk and Nessie tape. Okay, and then we have reference data in remote stores for sensitive data that will be allowed at some point. Okay, we are supporting some deposits and using or utilizing trusted remote storage, but those again have to go through a process of approval with our repository before you can use those. So when is data large for Harvard? So what I just talked about was what we do support, right? If you are at the 1 terabyte total project limit for your content, and you don't have thousands of files, then you're welcome to upload directly onto the repository interface. If you have lots of files, we have tools that will help you do large batch uploads of your content. But again, we want to really promote not putting more than 500 data sets inside a data set for usability reasons, right? For a Harvard affiliate, you get 2.5 terabytes for your total project, total account. And so once you get over those total storage allocations and your files are larger files in size, larger than 2.5 terabytes, hundreds and thousands of files, then we want to talk about large data, okay? So we have mapped those out, and you will also see this this image and this guide in our intake form for large data. That intake form walks you through the process, and if you don't have sufficient information to require large data, then it will tell you to contact us if you need further assistance to upload your data via the UI. But if you do fall into large data needs, then it will also lead you towards the right options for your data, depending on the frequency of access and how many files you have. Okay, and then looking at the budget. Always keep in mind that the Harvard Dataverse Repository does not support sensitive data. So all of your data still needs to be anonymized and de-identified and shared under managed access workflow if you are sharing such content on the Harvard repository. So we had to talk about building and delivering the sustainable large data service over the past few months, right? So we have the technical portion of this, the curation portion, and the administrative portion, right? So technically, we had to set up the infrastructure for support, working through our Harvard University IT and other systems at Harvard that have this connection with places such as Nessie and AWS, right? To establish these services. From the curation perspective, we're going to talk to you about how to package your data for proper storage into these infrastructures, including your anonymized data, managed access, and use of our add value feature, such as guest books, when you are sharing your data and preparing your data. Because if it's not packaged properly, it will not work well with the system, and it just won't be supported. And of course, there's an administrative piece of this, because this is a collaboration between our group and the finance team at Harvard, because this is a paid service. So in order to have this service, we're creating draft budgets for you based on your intake form. We are sending you an invoice that needs to be paid before the collection page you create is customized to support the infrastructure that you have selected or we have recommended for your data. So we're reviewing in your intake form to learn about your data project, to learn about the size of your project, to learn about the number of files, and the type of data that are being shared, and to ensure data are anonymized before it's shared. All right, so storage and access data arrangement and backups were all done by our team, right? And to determine if you're using a particular type of storage, what would be the cost, including the backup, and any associated development cost around it. Data representation, metadata, data access, and special requests are going to be managed by our curation team. And then, of course, the sustainability, the service coordination, invoicing, and monitoring is done in our collaboration with our curation team, our developers, and our administrative team from financing. So challenges and considerations in the technical aspect, right? Storage and access. What are the data storage costs? Data transfer costs. Where are your data living now? Where are these large data living now, and how are you going to get it into the infrastructure that we are supporting? File access costs, right? First of all files that you put onto the Harvard repository, even in the large data support, you don't charge for file access. You may have a managed access workflow tied to your account, but we don't support commercialization of data that people have to pay for access. User data and application and data interactions, right? Figuring out how the user is going to interact well with the system in terms of understanding the upload of data using the Globus integration, and then the download of that data by users. And then, of course, computing access. So data arrangements, as I talked about, we have graphs that detail the file size limitations, the file count limitations, and of course, we have to talk about backups of the data, which systems are providing backups. There's a question on the intake form that asks you if you need backup, because sometimes that costs extra depending on which storage infrastructure you are planning to utilize that we make available. Curation, right, challenges always. So we want to make sure that, of course, your data are shared well for discoverability, for accessibility, for interoperability, right? So custom metadata extraction, you want to include as much metadata as possible when you create your collection page, because you're still doing most of all of the work is done in the UI, right? You can use the API to do it. You can go through the UI, but we still need a description of the data set. We need the metadata that describes the data set and describes the fact that these data are being hosted in a large storage infrastructure and pointing to the instructions for the user to download the data. All right. And arranging the files properly. We've already had a number of use cases where files were not arranged properly. It was not a nice case to have to clean up. So those are things that we want to avoid ahead of time. The file packaging is really important. Data access, right? So is your collection going to be versioned? Because if you're planning to version your collection, then we have to take into account the growth of the collection and the costs associated with that. Restricted content still has to have managed access enabled, right? Retention periods of the data. So with our large data infrastructure, when you submit your intake form, we make it clear that we are storing the data for 6 years. In 6 years, you will get contacted again about whether you want to continue using the large data infrastructure that you have, point you to any new large data infrastructure supports we may have, or move your content to cold storage, because cold storage is another option that's there. What that means is that your metadata are always visible. It's going to just take longer for the data to be accessed, but you're not going to take on extra cost, and the data won't go away. The data are still preserved and accessible. And of course, we're still thinking about visualization, data exploration, and analysis support, because right now what you have is the ability to interact with Globus, and go and upload the files, interact with Globus, and go and download the files. One of the things you're going to see is that you cannot do this work via an API. That is not available yet. You cannot download and upload via API, and that's really important to stress, especially when you have a lot of data, and this is where packaging becomes very important. Because you're not going to be able to do any of this work via the API at this point. It's all things that we're still talking about and discussing and figuring out how to provide. So challenges and considerations on the administrative end, right? Addressing diverse use cases with the solutions that we have now. There's a lot of cross-organizational workflow that takes place here when you complete a request form. One of the things that it does is it triggers a ticket that comes throughout our support system. It's assigned to a particular person. In this case, it's me. We review it to ensure that you've selected the best large storage option available for the type of data that you have or with the information you've given us. We create a budget for you that we send to you to review and approve. And then we have to send this off to our finance team to prepare an invoice for you. So there's a revenue sharing agreements that we go through, right? In terms of support, where the payments go. Account management, there's collecting funds from both Harvard and non-Harvard group. It's always easier to collect funds from Harvard than it is from non-Harvard group. So these are all things that we had to work through to be able to provide this service. And I have to say that, we've gotten quite a few, we have quite a few in process right now, a few support inquiries, and a couple of very large ones that we've done for our use cases in this pilot phase that we had. So it's looking like the need is definitely there and the workflows are coming together. So we have pre-service support, like I mentioned. When you send us your intake form, we are going to review your form. And if we think that there's a better option for you in terms of cost and storage solution, we're going to go ahead and advise that for you. In terms of curation services, we will ask you to create your collection, and then we will customize it for you. And we can also available for consultation on how much metadata you should include, and including the information about your data being supported in a large storage infrastructure so that users can be guided to the documentation for download, okay? And here's the workflow. Client support with the large intake form curation. There's a consultation option, the invoicing and provision for the different services. And then, of course, finally uploading, publishing, and sharing your data. So here are some of our services that we offer, okay? Along with large data, we do have our regular paid curation services. It's based around the same prices here, right? For doing some of the work for you. Now, what you have to understand is that we cannot always access your large data. Your large data is usually somewhere that we cannot put it on a laptop. You have it on your own system. You have it on a hard drive. And this is work that you should count on doing yourself when it comes to large quantities of data, okay? In terms of pushing it into the large infrastructure using the Globus integration, and then users will be able to download it, and reminding users that they need to have enough space to download these large quantities of data. So again, we have large data curation, training, blogs, conferences, this being one of the webinars that we're doing. Tomorrow on site, we have a hands-on training at Harvard for using Dataverse. And then there's also a large data working group in our Zulip channel, if you have not joined that or are interested in joining it, depending where you're coming from. So costs, just so you know, S3 Nessie disk is forthcoming. There's a separate egress cost when you use AWS S3, right? So that egress cost has to do with download. So when you're using tape and disk, you're not paying for these additional download costs directly, right? Because you could have data that's very, very popular. We have a data set right now that's really popular, and it's very large. It's 16 terabytes. It's on Nessie tape. We have some content that's coming into Nessie disk. You're not paying for downloads there, because if you were, it would be very expensive. Just to give you an idea of the difference in cost between the infrastructure that you select. We do charge 15% on the storage cost for Harvard, 20% for non-Harvard, and the 6-year minimum commitment to having the data up, unless there's a legal reason that data needs to come down. So we recently, as part of our National Institute of Health Generalist Repository Ecosystem Initiative, published our big data use case. It's published in Zenodo. So you have a link in the slide to the Zenodo white paper on defining big data, right? We talk about volume, variety, velocity, and veracity, about special infrastructure, functionality, or handling of large data. This is actually one of our projects. Our last large project, 16 terabyte project from Decode Lab at MIT that we started supporting late last year. Did a lot of repackaging work with them, and this really helped us to refine our documentation that Leonid will talk about on uploading and downloading and packaging data to move it into the system, okay? So just to reiterate the steps, the large data support website has this intake form that we require for all requests, because it's going to give us enough information to help you determine the right storage you have and provide you with an invoice and a draft budget that you can agree to, or redo your intake form to request something less expensive. A Nessie disk is slightly more expensive than tape, right? So things to consider. So there's that. There's the consultation part if you need consultation with our team. We go through the invoicing and then uploading, publishing, and sharing of the data. So that's our large data support website. The first link you're going to find is the intake form. We have links to those documents here, and we have links to our documentation, which are really important. The README for the Globus, data upload instructions, and data download instructions. This is just some of what the intake form looks like. It's going to ask you to describe your project, the total size of the of the project, the total number of files, because that's really important, agreeing to either 6 years or more of storage. We collect some questions about why you're using Harvard Dataverse. That helps us, right? Any conditions that's going to prevent you from data repackaging. We did have a use case where they could not repackage the data as needed, and we could not support it because the infrastructure requires that data be repackaged for each infrastructure, that they have to be repackaged a certain way. And we had a use case where they could not do that. Do you require managed access? Are you going to be doing versioning? Because again, with versioning, we have to take into consideration an increase in price for the versioning period. And we are going to ask you to have the data anonymized. If it's not, and that's not a service we provide, anonymization takes a lot of work. So you will have to agree to anonymize the data before it is shared. Every time you create a ticket, it comes into our support queue where we tag it with the information and what you need to share, and which storage option you are selecting, and also your affiliation, so we can always manage your content in our large data support queue. And when I talked about the file packaging for large data support, so take a look at, when you're using Nessie tape, what you have to do in order to package the data well. 100 megabytes minimum per file size, preferred 1 gigabyte to 1 terabyte, 10 files per gigabyte for the file count. Nessie disk is 256 per gigabyte files. 2 terabytes is the maximum. 1 terabyte for S3 Nessie disk, which is going to be coming, and then 5 terabytes for AWS storage. Okay, so these are all things that have to be adhered to when you're selecting your infrastructure for support. And in the intake form, it's going to show you this as the last question, and it's going to ask you if the option you've selected for storage, if your data can be repackaged. If your data can't be repackaged and you select no, it's going to start the intake form again until you select an infrastructure for support that actually will work with your data. All right, I'm going to have Leonid is going to take over because he's going to talk about the integration a little bit and the workflow, and then we will have a demo, and then we will take all of your questions. Leonid, it's for you.
All right. So basically, this slide and the next couple of slides are basically are there simply to illustrate the point that for those of you who are already familiar with how Dataverse works and how our workflows are organized, that it's basically a mix of the familiar Dataverse UI and familiar Dataverse features and some brand new components that had to be added to accommodate the Globus specific workflow. And again, I just want to spell out what Globus is and what it offers and what extra limitations it introduces, because this is a super important part. Yeah, I'll share my screen in a second.
You want me to go to the next slide?
Actually, yeah, and the next, perhaps the next one after this one.
Okay, actually, yeah, so let me just talk really briefly here. So what you saw before was the download. So what we had was the screenshots for what you're going to see when you're depositing data via Globus. And then we have some screenshots, and these are all in the README file of what you're going to see when you're downloading data from via a Globus, because you still have to connect to Globus in order to do both. And what I did want to show you was the 2 Harvard repository use cases. One is the OMAMA project, which are about mammograms for detecting breast cancer. It was actually our first large data use case that came in from an affiliate with CEAS. And if you look at the size of the file, there's a 7.9 terabyte file in this one data set that if you try to download, it's a tar archive, will ask you to connect to Globus. This project is also utilizing a guest book. So this guest book pops up as soon as you try to download or click to download the data. Even before Globus shows up, you're going to see a guest book to complete for this author. What you also notice is this collection has 2 data sets. If you actually go into this first data set, which I didn't highlight here, the files are smaller than terabytes. Which is okay. What you're going to notice, though, is that the entire collection is using the large storage infrastructure. So one of the things you're going to adhere to is that when you create a collection, we are setting the storage option at the collection level. So all of your data sets, regardless of being extremely large files or extremely small files, are going to go into the large storage infrastructure that you selected. What you're not going to do is have a data set that has 8,000 small files in it. We're not going to do that because that doesn't adhere to the packaging at all. Having a data set that has 2 small files in it is workable with Nessie, but having one that's 8,000 small files, it's not going to work. That's why we have this larger file, 1 tar file that's 7.9 terabytes in here. The other use case we have, this is really a popular one, is this driver net large-scale multi-model card data set that's coming from a lab at MIT. They're also utilizing the guest book. As you can see, there's a lot of documentation about the Nessie storage directions. We've added that as metadata, not only in the collection space, but also at the data set level. And then the terms page, so people can see exactly how to download the data, points you to the instructions. And as you can see, they have 7, not extremely large, but if you look at it, it's 11 gigabytes, 12 gigabytes, 11 gigabytes here. They have 5 data sets. In total, though, that's 16 terabytes of data that they're sharing for this project. All right. Leonid, go ahead and take over from here, and I will. All
right. So yeah, Sonia mentioned that these slides are going to be shared. After the webinar, they contain all the links to the documentation that we are offering to the users, to the end users, and basically anyone who is seriously interested in actually taking advantage of these large data storage services are strongly encouraged to review these instructions to get a good idea of like what the process is going to be like for you, and even more importantly for your users who will be downloading the data. Okay, let me share my screen real quick. All right, you should be seeing the GitHub page with the documentation. So once again, Globus is the word that has been mentioned repeatedly. Basically, we are offering these large data services. This is a collaboration between us and the Northeastern Storage Exchange. So they are basically through this collaboration, we can offer access to some like mind-boggling amount of space. They have hardware. They basically have like petabytes of storage, and it's readily available for us to use. The limitation there is that storage is only accessible via Globus, which is like a protocol essentially dedicated for large data transfers. Anyone who has ever tried to download a gigantic file in a browser, I mean, knows like you have to like sit there, especially over a slow line. You basically have to sit there and pray that your computer doesn't freeze in the process, or there is no network loss anywhere in between, because that basically means that you have to start from scratch again. Globus essentially solves that problem. It's a service that will handle it all in the background. You can shut down your computer, you can unplug it. Next time you turn it back on, it will continue from where it stopped. So so as Sonia mentioned, we already have like real user cases in production with people, with data files that are in a terabyte size. I think I saw recently somebody from China downloading these terabyte size files over what must be an exceptionally slow link. And it literally, I saw that basically that download was happening for, I think, 5 weeks total, but it actually succeeded in the end. Like you cannot possibly run a download for 5 weeks using like your normal like browser HTTP access. So just like with everything else, for that extra power, you have to pay with something else. And basically, the process becomes more complicated. There are extra components to install, and you definitely lose some convenience. So one important thing is that what Sonia just mentioned, that there is, to access something that's only available through Globus, it has to be done on the web, partially because of how Globus authentication is organized and for some other reason. So there is essentially no anonymized access. Even if you have publicly available data that you are willing to share publicly, it will still require a person to have a Globus account to authenticate. There is no possibility of essentially just giving somebody a link and for another researcher to plug that link into their Python script and have the script automatically obtain the data. Basically, some human interaction will be required. The user will need to first download this chunk of data following like using the Dataverse UI, and then only then you can feed it to your computations, etc. But again, the nature of this service is that we are offering it to researchers with use cases where no other ways of actually being able to share the data are available. So again, if you have a single 8 terabyte archive, you can just place it on the web and expect anyone to be able to actually download it. Just a second. So again, so Globus operates again by running transfers between Globus repositories. So basically, this one extra component called Globus Connect Personal is offered for free by the Globus project, and it essentially turns a person's like personal computer into a miniature Globus repository. Then the transfer basically happens between that repository and the source of the data. In this case, the Harvard affiliated storage volume at NASE. And I will run a quick demo again for those of you who are familiar with how file uploads work in Dataverse normally, just to illustrate the extra steps. And So I already followed the user instructions and I installed that Globus Connect personal Excel component. I can now proceed to upload the data. So this data set is on our server called demo.dataverse.org. As the name suggests, it's basically where we encourage users to essentially test Dataverse and experiment with it. Pretty much anyone can create a data set there, but you will need to talk to us to actually have the data set be connected to the Globus enabled storage. But again, anyone who is seriously considering actually ordering this servers from us, I encourage you to actually try it first on demo, and again see if that fits your requirement. And again, to get a good idea of what your users will actually need to do in order to obtain this data. Again, so far this basically looks like any other Dataverse dataset page. And again, you get all the usual Dataverse features. It offers very rich and powerful mechanisms for curation, for entering and refining the metadata associated with the data set. You can create guest books to have a good idea of like who is actually using and downloading your data, etc. But let's say I'm clicking on upload. So basically, yeah, now since the data set is configured to use Globus, I have this like upload with Globus button. So I made sure that I'm logged out on the Globus side, and it is now sending me through this extra authentication. And now that it has succeeded, it bounced me to this extra UI that you normally don't see when you are using Dataverse with like our traditional storage methods. So I'm obviously not trying to upload any like terabyte size files for the purposes of this demo. It's some reasonably sized files. The UI is fairly Spartan. Again, I think it's important to point out that this Globus integration is still somewhat experimental. It's the newest feature in Dataverse as of now. So all of this is under like constant, basically all of this is subject to ongoing development and refinement. Okay, I selected the file, I click submit transfer. There is now, so one thing you can see here in the corner is this this animation is showing that there is some transfer actually happening between Globus and your computer. And you can use the existing Globus infrastructure to actually to monitor that activity. So again, it's already succeeded since it was a tiny file, but again, if you are uploading terabyte size, this gives you a convenient option to a convenient mechanism for monitoring the progress. In the meantime, the file has now magically appeared in your data set on the Dataverse side. So this of course looked very straightforward, but again, it's important to know that it will take much longer for any truly large data. And most importantly, again, Sonia, I think, mentioned it a few times. One thing we learned the hard way is that this system is not working particularly well for like for a use case where you have like large numbers of relatively small files. So basically, with thousands of files in a data set, this system isn't working particularly well, or at least not in any kind of user-friendly manner. So we strongly suggest that basically for any kind of a use case where there are indeed like thousands of files, that they are repackaged in much larger bundles. So again, our real life example is that a MAMA data set with radiology images that's basically all packed in one gigantic 8 GB tar file. It may not be necessary to go to such extremes, but generally that illustrates the case for which Globus is best suited. And if nothing else, it's actually a mechanism for like filtering out I don't know, people who may be just mildly curious about your data from, from those who are like truly dedicated to obtaining the data. So I'll pass it back to Sonia, but basically the main point I was trying to make is that, yeah, this extra, this ability to store like truly large chunks of data comes with some limitations to how easily the data, your data files will be accessible. So yeah, for the record, I'm not gonna like demonstrate it, but essentially for somebody who will now try to download this file, the process is essentially the reverse of what I just showed. It will be a user will still have to will essentially have to perform the same steps of authenticating with Globus, of using the same Globus extension, and initiating the transfer between the source and their own personal Globus endpoint.
Okay, great. I think I've managed to change the setting on the webinar so that we can see who's here. It's a small group, so. And then, of course, you can ask any questions out loud instead of using the Q&A, but I think somebody did put something back in the Q&A. Globus transfer can be done with a Canon HPC cluster and Dataverse, right? That's the question in the QA. Leonid, Globus transfer can be done with the Canon HPC cluster and Dataverse.
Okay, hold
I'll
on.
put it into the, if you're not on Q&A, I'll put it into the chat so you can see it.
I may have actually lost the Q&A window.
That's all right. I put it in the chat.
Because, no, I still, okay, I have to confess, I don't know what Canon HPC cluster is, but basically if it is a storage repository that offers a Globus endpoint, then the answer is yes. So once again, Globus will work between any two Globus repositories. I focused on using that Globus Connect Personal because that's like the most popular case of people essentially transferring between Nessie and their own computers. But generally, if you have access to some institutional Globus accessible storage, yes, basically this extra Dataverse UI that I just demonstrated, it will happily perform transfer between basically any two Globus endpoints where you basically authorize to either read or write.
Okay, the other question is, oh, Ilya just put the link into the,
Perfect, thank you.
yeah, just put the link in there. Okay. Any other questions? Great. Well, we appreciate folks showing up today to learn more about the service. Feel free to let your community know about the service. I know we've been talking about this with folks that are in our large data working group who have installations and wanted to know more about how we provide our service. So, you know, send us any other questions you may have on email through our support system or directly if you have our email, and we're happy to chat about what we do. Thank you so much for attending. Thank you, Leonid.
Thank you so much.